Welcome back. It is the continuation of our previous looping statement lecture, where we have seen the basic purpose of a loop statement, why it is necessary, and we have discussed that C programming supports three different ways of writing looping statement through the for loop, while loop, and do loop. And followed by this, we have started discussing how for loop works, what are the required syntax for it, and we have developed one very basic program, multiplication table of a particular given number. Okay, and at the last we have also discussed the importance of the updation, why updation is very much important. What will happen if we miss the updation? A loop can infinite. So let me just run it again so that you can recall what we have covered. Okay, so loop is continuing here. Let just control C, it will stop. Fine. So let me just write the updation. In this lecture, we're going to see more in detail about these three things: initialization, condition, and updation in the for loop. And different combination we'll try. We'll write the for loop without initialization. We'll see. We'll also write the for loop without condition, and we'll see instead of positive updation, is there any possibility can we do the negative updation as well? Okay, so how to do that? Fine. So let's come back here. Previously, here I have written the procedure that I equal to 1 and the variable is declared outside of the for loop. This is the style of C89. Later, when C99 was introduced, during this updation, they made some changes. Okay, so what they suggested in the standardization, no need to declare the variable outside of the for loop. You can declare and initialize at the same time within the for loop. So now, what is the difference between the previous one and this one? Let's try to understand this. Okay, so before I just come up with the C99 syntax, here let me just uncomment and continue with the C89, and after the outside of the loop, let me print the value of I and see something, and let us see what value of I is there outside of the loop. So now my multiplication table code is okay, there is no issue. Let me just remove the unnecessary spaces. I am outside of the loop, and now let us print I equal to this in a new line, and I run it. Okay, so it is waiting for a number to get the multiplication table. Now see that variable I have declared here. Okay, line number 5, I can access it inside the for loop, and even though I can access it outside of the for loop. So during the discussion of the for loop, we called one term that is called loop control variable. I hope you remember. I have written it somewhere. Okay, in the screen I think I have written loop control variable. So, but is it loop control variable? Although it is working as a loop control variable, here it is controlling through this condition how many times the body of the loop going to execute. But I can access this I from before for loop. I can also access it after for loop. So this variable I is not meant to work with the loop directly. It is available throughout the code. So what C99 is introduced, C99 introduces that if you want to use a variable within the for loop only, and after the for loop, if you do not want to use that variable, you can declare the loop control variable at the same time when you're going to writing the for loop. So now this statement is not only initialization, it is declaration along with initialization. So now let us try to access the I outside of the for loop, and let's see what is happening now. Okay, so I get the error here. It says that I undeclared. Okay, so but here you see you can argue with me that I is declared here. That is the difference between C89 and C99 syntax. Okay, so remember this particular thing here. In C99 we have two way that we can work with the loop control variable. We can declare it outside, or even though we can declare it at the same time when we write it in the for loop. So the mechanism is different here. Try to understand, there is one concept called scope of a variable. Scope. okay, scope, up to what extent in your code you can use that variable. If I declare that variable outside of the for loop, and if I did not redefine it here, redeclare it here, so this I will refer the I that I have declared outside. So even though I executed or exited from the loop, that variable is still live and I can access it in my remaining part of the code. Okay, but if I did not declare that variable outside of the for loop, but I declared only within the for loop at the time of writing a for loop, now accessing this variable outside of the for loop is illegal, because the scope and lifetime of I is within the body of for loop, within the body of for loop. I hope it is clear. Within the body of the for loop. Clear? Okay. So remember, if you just want to use any variable that throughout the program, and you also want to use that variable along with in the for loop as a loop control variable, you follow C89 standard. And if you do not like that, and if you restrict the use of loop control variable within the loop, go with C99. Okay, so in GDB compiler they come up with C99. You can use both simultaneously. But if you are using some offline ID like div C++ or code block, I think you need to change your compiler settings flag variable, okay, or environment, something where you need to write -std C99 somewhere. Okay, you need to define the standard of the compiler. Okay, so this is the first thing I want to tell here. Now second thing, so we should stop use of I, right? Okay, fine. We get the output. Can we mix both the things? So let us try. So I have opened I here, and let us now try. Okay, no error. Now see, the value of I prints 0. Okay, so which I it is referring? Okay, I think it is clear which I it is referring right now. Okay, so it referring the I that is declared outside of the for loop. So this I that I want to access, it's referring the I that is declared outside of the loop, because here I have redeclared the I, so it is become local I to the loop only, local I, and it is not the local I, it is referring the I which is available within the block. So now in this code there are two blocks. This is the block number 1 and this is the block number 2. So this is the larger scope and this is the smallest scope or smaller scope, only within the loop. Okay, fine. Okay, now let's move further. We have seen that if we miss the updation, the loop can go infinite. Okay, so now let us miss the condition. Let's see what is happening. Run. Okay, no issue in the code. 2. Now see, again it is infinite. Okay, again it is infinite. Why? See, try to understand. Okay, this is the main thing in C programming. You need to, if you only stick to the basic syntax, you will not learn the features. So later you will face the issue. So everything you have to trial and error. Okay, so what is the issue here? See, the initialization is perfect, updation is also perfect, but condition is missing. No condition here. So no condition means, suppose this is the gate of your house and entry gate, and there is no gate. So what it means? It is open for all. Anybody can easily come now. So here also, if there is no condition, so while entering, it is going up I2. Okay, no condition. No condition means true. Simple. No condition means condition is always true. Remember, 3 true, 4 true, 10 true, 100 true, 12 true. So it will become an infinite loop. Okay, so another way that you can do the stuffs as infinite loop. So let us control it here. I less than equal to 10. Fine. Now, another way, can we just miss the initialization? Let us try. So I have missed the initialization. Now what I have done, I have shifted the initialization outside of the for loop. So let's run it now. You can see it is a finite loop and I get the output properly because I did not declare the I again in the for loop. So this way also it is possible, means even though if you miss the initialization, you don't know the initial value might be, it is taken as an input from the user. So that thing also it can be done. Okay, so don't need to worry here. You can also consider as an input from the user for the initialization of that loop control variable, right? Okay, last one, can we do all this stuff, can I just remove that updation from the loop? Can I run the loop only with the condition? Is it possible? So I hope you remember, if I miss the updation, it will be infinite because I will be remain as 1. So what we can do, in the last lecture I told you that updation will be the last statement of the body that is going to executed by the program control before it is checking the condition for the second time onwards, right? Okay, so instead of writing the updation within the for loop, we can do the updation at the last statement of the for loop. Okay, so now let us see this. See, we get the correct output. Loop is finite, so we done the updation here. Okay. Next, this is what this is done, initialization. Initialization. Okay, and now last one, can we do the same thing with the updation? Can we remove the updation? Can our code will execute? I told you that if we miss the condition, sorry, if we miss the condition, loop will be always true. So please write here, without a condition, loop will be always true. So if loop is always true, without the condition, it will be infinite. Okay, so then how to control? So here, inside the body also we can write the condition. So if I less than equal to 10, then print this. Then print this. What if I become 11? So can we do this? Break statement I have already introduced in the switch case. So will it work? Will it work or not? So let us just see. Run and take a number 2. Now see, my loop works perfectly. There is no issue. It started with 1, it prints up to 10, and my loop also terminates. So see, I have written a for loop completely empty, no initialization, no condition, no updation, because now I shifted the condition here. So now how it works? So now instead of 10, let me just execute it up to 3 so that you can understand, right? Okay, because same thing will repeat now. Okay, so let me just evaluate here. See how it is works. You have started the initialization I equal to 1. Okay, I equal to 1. Try to check the initialization first. It say nothing is there. Okay, move to the condition. So there is no condition, always true. No condition is always true. Remember, no condition is always true. Now checking further, what is I? I is 1. So what you are checking? I less than equal to 3. Is it true or false? It is true. So it's going to print me 2. I have entered 2 now. Yes, 2 into I. So I is 1, 2. Fine. and if is executed, else will not execute it. So it is coming to the updation I plus plus, so I become 2. I become 2 without no condition. Again it is true, so again it is checking I equal to 2 less than equal to 3, true, yes it is true. So now let us print this. Okay, and again it is coming to the updation, so it's now become 3. I equal to 3, again in entry level no condition, which it is true, so we are checking condition here. Is it true? Yes, it is also true, so print it. So done. Now it is going again for updation, so it is now 4 going up. So now checking I less than 4 less than equal to 3, so it's become false. It's come to the else and it meet the break statement. So what break statement will do? It is going outside of the body of the loop. Okay, outside of the body of the loop. Clear? So now if you want to remove the condition from the loop, okay, loop header you can say, okay, that condition need to be handled inside the body. Okay, initialization can be shifted outside of the for loop, but other two things need to be handled within the inside of the for loop. Now in such case, when we write a for loop without updation, without initialization, without condition, what it becomes still an eligible syntax in C programming, these two semicolon. So semicolon without anything is considered as a null and valid statement in C programming. Remember, let me show you. Look at, I put a semicolon after scanf. No compile time error. My code works. So okay, let us put more semicolon, semicolon, semicolon. Run it. See, no compile time error. My code works. Okay. So a for loop, what is the minimum requirement? Can the loop execute without semicolon? Let us try. No. See, it is saying that some token is missing. It is guessing some token is missing, not the guessing the exact token. So exact token is semicolon is missing. Okay. So can a for loop execute with one semicolon? No. It says again some token is missing. Okay. So can works with two semicolon? It's fine. No problem. We get the output. Got it? So minimum requirement is two semicolon, and semicolon without any statement will be treated as valid null statement. So in a loop, specifically in for loop we are talking about right now, you can shift the initialization outside of the for loop. You need to handle the other two things, condition and updation, within the for loop itself, right? And the updation will be the last statement of the body. And if you are putting the condition inside the for loop, you need to use the break statement. So when the condition is not met, you should came out from the loop. Else it will execute infinite amount of time. Okay. So here, if I just put this else statement in comment, let me show you. So it is waiting for the input. See, although it is not printing because of the if condition, it fails. 4 less than equal to 3, and later it start doing some stuffs. My program is not stopped here. So that's why if you shift the condition inside the for loop, you have to take in care the termination of the loop with the break statement. Remember, break statement is only we used with the loop other than switch case. You cannot use break statement inside the if and else without a surrounding loop. So here this for is a surrounding loop of this if else statement. Okay, so I hope you understand the very important part of the for loop syntax. Still we have not tested, let me check the time, sufficient. We have not tested the negative direction of the for loop. So let me just take 1 or 2 minutes and let us just see the negative updation is also possible. Okay, so negative updation means what? Negative updation means initially, if you remember, we started I equal to 1 and we go up to 10, and every time it is updated by 1. So this is positive updation in positive direction. We can start the stuffs from 10 and we can reach up to 1 or any number in negative direction we want. And every time, instead of incrementing, we're going to decrement it by 1. It is also possible. So how we can done? We're simply going to modify the updation from I plus plus to I minus minus, and the initial value, instead of I equal to 1, it should be the last value of the I equal to 10. So let us print the multiplication table in reverse direction, and this will be the last example of this lecture. Okay, fine. So let us start I equal to 10, and now I also need to modify this greater than equal to 1, because I no need to print the multiplication table on negative direction, minus 1 minus 2, and here instead of updation as a increment by 1, I'm going to decrement it by 1. So now let us print and see. Now check the multiplication table. It started into 2 multiplied by 10 and ends with 2 multiplied by 1. So this is negative direction, right? So how we have achieved this? How we have achieved this? Careful. In the when you do the negative direction, the initial value should be the last value of the loop, and the last value of the condition written. Okay, the condition written, the which value you are checking, it should be smaller than the initial value, and you are using a decrement operation in an updation statement. So if you suppose, sir, what will happen if I do positive updation? Again, it will be infinite. See? Careful. Okay, so the combination in this way it will work. So please practice more question. If you need more practice question, more demonstration, please let me know in the video comment. Please do like my video, and please do not forget to subscribe my channel. Thank you very much. Have a nice day.